and welcome back to day 3 of Conexkt Days. This is our second session of the day, so thank you so much for joining us and for tuning in. For those of you that are staying from our last session and are from Europe, good on you for staying up for a late night. We are really glad to have you. My name is Tiffany, and I will be your host for the week, and I'm joining you live from Conexkt, Canada. As mentioned before, on our website, conexkt.world/2020, we have a listing of all of our speakers and their dedicated session times. If this is your first session with us, please note that we are also using a digital tool called Conversation Starter. It's a great tool to schedule one-on-one appointments with other attendees, and we have over 173 this week. So make sure you head over there and make your profile. That is a lot of meetings that you can have. Also, during this session, we want to hear from you. There are Q&As throughout the sessions, and we are looking forward to all of your intriguing questions. Just click the Q&A button at the bottom of your screen to send in all of your questions. We will also have polls throughout the sessions, like the one that will pop up on your screen. We are wondering, how did you hear about the event today? How did you hear about the event? Maybe word of mouth, maybe social media. Let us know so we can spread the voice of innovation much farther. Let's see here. We have a couple more that we have to come in. We spent about 30 seconds, give people about 30 seconds to be able to send in their answers. And let's see what we got here. Looks like most is LinkedIn and personal invitation. That's great. Now, for this session, we are delighted to have with us two speakers, Eliane Maalouf as well as Daniel Hladky. Our first speaker will be Eliane Maalouf, and is our own intelligence engineer at Conexkt. What a fun title to have. Thank you so much for joining us. And I will welcome her to the screen now. Welcome.
Hi, Tiffany.
I'll let you take it from here.
Thank you. Good evening, everybody, or good morning, or good afternoon, depending where you are. I will start sharing my screen with you. Okay, I hope you can see.
Yeah, we can see.
Perfect. Okay, so to our session today with Daniel is going to try to demystify artificial intelligence, but really from a business perspective. My part of this presentation is to basically give an overview about the technologies, and then I will move I give the word to Daniel for the discussion about more practical aspects in the business context. So as Tiffany mentioned before, I'm an engineer at Conexkt, and in parallel, or let's say my main occupation is I'm a PhD student in computer science at the University of Neuchâtel. Before starting with something more, let's say, more into the content of artificial intelligence or machine learning, I would like to speak about a distinction I would like to make between data science, machine learning, artificial intelligence, and statistics. These terms often appear together. Sometimes they are used equivalently, and sometimes they are distinguished from each other. And sometimes it's not clear what do we mean by each one of these. And I think the distinction is important. I would like to think about, I usually like to think about data science as more of a process, actually, which starts with identifying a question, an interesting question to answer, or maybe, I don't know, a hypothesis we would like to verify. And then it moves into getting some data or collecting information, exploring what is in the data and understanding the hypotheses that we can make from it, and then model it and try to use some tools in order to extract real information that is in there and communicate about it, and basically reiterate and ideally evaluate what we did in these different steps before. And the nice thing about this process is that, as you see, it includes a lot of activities, but also structures the whole let's say investigative work in data science. And it's not, then when you understand data science in this way, you're less surprised when you see data science this job posts that require really a lot of things, and you basically you're not sure if these people really exist. Sometimes they ask of these data scientists to know how to manage databases, how to collect data, how to visualize, how to communicate effectively, how to, I don't know, sometimes the PhD, no PhD, you really don't understand. And probably there is this mix of requirements. Is because actually data science is a process and it's not one specific functionality. And inside this process, modeling the problem could be done in with two big families or two big approaches of modeling. One is based on statistical modeling, which is, let's say, the more traditional way, and one is based on artificial intelligence. And I would like to specify here is that machine learning as a domain is part of artificial intelligence. And very simply put, the distinction between the two approaches is in the goal mainly. Statistical modeling needs actually, or tends more to work on inference, basically to explain the underlying mechanisms that generated the data. So we're trying to find relationships or variables of importance that can explain what we're observing. Artificial intelligence, and more specifically machine learning, work more on a prediction objective. And ideally here we would like to be able to forecast accurately some outcome from unpreviously seen situations. And the distinction is made easily by a very common example, is that sometimes you could apply machine learning on some data and you can find some spurious correlations. For example, you can find that high consumption of ice cream is related to high shark attacks in some regions. And actually, if we just take this information that was discovered, for example, by a machine learning algorithm, and we think about it, it doesn't make any sense. And here, the goal of statistics is to actually prove, or let's say validate, such relationships and prove the significance of their existence. So we can see them as separate in goals, but they are quite complementary. And sometimes we can do both, but statistics is much more available or possible, let's say, when we have a smaller number of variables or let's say of smaller data sets where we can actually interpret many of the results that we have. Artificial intelligence and machine learning in general are much more used when we have very large data sets and very large number of variables that we want to integrate in our modeling. From this distinction, I would like just to say that artificial intelligence started as a quest for replicating human intelligence in many of its aspects, from perception, like really physical senses perception, to reasoning, to decision making, to planning, and all these things that we do quite naturally. So the first goals of artificial intelligence were in that sense. And actually, it is composed of many types of technologies that I will categorize in four. The biggest one, or the one that is actually getting a lot of attention lately, is the machine learning category of techniques. It has groups of algorithms that have basically two goals. One is to classify, so from a series of inputs, from a series of variables, and as an input to an algorithm, we would like from the output to predict a class. For example, we would like to predict if the car is seeing a tree, a human, or another car, for example. Or if we're receiving an email, can we classify it as a spam or no spam? Whether regression is more on predicting quantities. So we would like, I don't know, to predict the evolution of price, or we would like to predict the probability of an event happening in the future, for example, a probability of a purchase happening in the future. And it is basically it's the machine learning algorithms are basically also grouped in 3 approaches. The most common one is a supervised one, where the algorithm is given a task to learn, but is also given during the training a kind of a teacher, an information, a feedback about what it's doing right and what it's doing wrong in order for it to learn. A non-supervised technique would be more of we're providing the data to the algorithm. We're not telling it what to do with it. We're just asking it to discover patterns inside the data. And so we don't have this feedback signal to give to the algorithm. Reinforcement learning is more, you can imagine it more as playing a game. So we tell the algorithm to play a game, we give it the rules, and we give it the scoring mechanism. And we let the algorithm basically play the game and learn how to increase its score. And we actually, in these 3 categories and these 3 goals, there are many algorithms, but the most heard about one is nowadays is the deep learning one. And basically it's neural networks. So these are connections of small elements of calculation that are stacked together in a very long hierarchy of layers, let's say. And this stacking of layers makes it capable, somehow we still don't understand exactly how it's doing it, but it makes the algorithm capable of understanding and managing very large amount of data, and basically learning any function, or maybe a very large number of functions that could link the inputs to the outputs we're observing. So potentially a relationship between the 2. But there are others. I will not go into them tonight. But I put them here for those who have in the back of their head some names. So you see them in the machine learning category. But there are others, as I mentioned. You could find also probabilistic reasoning. Here, the goal is to actually learn logic relations between concepts with uncertainty in the data. So we're more learning let's say an unsure logical relationship, and we're putting some probability with it. Ontology engineering and logic programming is a big part also of artificial intelligence. It's actually one, like the main competitor, or let's say the main second category of AI compared to machine learning. And the ontology engineering and logic programming here, objective is to actually create an expert system, a system that defines the rules and the definitions of every concept in the domain. So basically it creates a knowledge graph of a domain. And the idea is to give this knowledge graph with the way we traverse this graph to a machine. And then on this graph, the machine can learn some new relationships and some new inferences. And the last one would be a new area, which is known as fuzzy logic. And it's based on the fact that the humans usually decide without imprecise information. So when we say when we talk about people length for height, for example, we say this person is tall, but it's not too tall. He's not too tall, or small, but it's not too small. So we have these, let's say, gray areas in our reasoning, and fuzzy logic is trying to replicate these types of reasoning inside the machine. So this was my my brief overview of the techniques, and we see that we have a lot of things happening here, but we hear a lot about AI through the media or on the internet, and we hear more about the let's say very cool applications. So for example, of course, you've heard about driverless cars. Driverless cars, for example, in order for them to work, they will need to make function a lot of elements, basically object recognition, vision somehow. So it's like we have to give vision to the cars. We have to make it detect and communicate with other cars. So multiple technologies need to be developed in order to make such application work. You have heard, of course, a few years back about Google Assistant that can now book you a haircut or I don't know, book you for you a seat in a restaurant by you just asking for it to do so. And here you can imagine behind this what needs to be done. So the algorithm or the machine needs to understand the language. It needs to connect it to different concepts, but it needs also to connect to a system in order for it to make the reservation. but also it replies to you back with voice. So it also needs to be able to generate a voice, generate also a sentence that makes sense to you, and give you the feedback. So you can imagine here that multiple technologies actually need to be in place to make this work as well. Maybe you have heard about these super computer programs that can play games. One of them is, for example, IBM Watson, that played a general knowledge game and won it, Jeopardy, a few years back. It was quite impressive because actually, if you slightly go and search how Watson needed what Watson needed to do in order to perform this, was actually to go through a huge knowledge graph as well. So it needed actually do two types of artificial intelligence. One that goes through a knowledge graph to help it crunch information and understand some of the concepts. And also it needed to capture from the environment the questions that it was being asked, and also to give back an information. So we can here, for example, we can imagine that maybe we got close to a real intelligence inside the machine. It's still a very nice and messy set of tools that was used there. More recently, you've heard maybe about AlphaGo that also won the Go game. Of course, you have the robots. The robots here, the impressive part is that these new robots actually learn to walk and run and interact with the environment in a very interactive way. They can move objects, they can adapt to new situations very, very quickly. And all this is based on this reinforcement learning idea where they play the game inside an environment where they fail and they learn from their failure. And they adapt, so they also have to perceive the environment. And here we see from these different applications that we're getting very close in specific parts, or at least in terms of functionalities, that we're mimicking quite well some of the human abilities. And most recently, we're starting to talk about creativity in AI, and we're talking about generating images, generating art, transferring styles, generating also videos, which doesn't always bring positive connotations to mind, because you have heard about deepfakes, which are actually generating harmful videos where they are putting people in contexts that they are not true. So they are creating fake videos in general. So these are all hypes, and they appear actually in very impactful presentations and very, let's say, they always appear in a very nice presentation. But we can always ask the question, what can they bring actually to the real world, right? They are basically increasing the expectations that someday we will be able to use these technologies every day. We're starting to see, of course, a lot of use of AI, but this level of, let's say, full AI everywhere, robotics and all these things, we're still not there. And the expectations are very high. And in order to understand the future of AI, I think it's worth looking at its past. And I would like to very quickly go through the past and the brief history of AI. Actually, the concept started in 1956, where there was a conference where the term artificial intelligence was coined and the academic field started. And then there was this first golden age of AI with also very high expectations and promises of solving human intelligence and logic. So basically training machines to solve logical problems. But the expectations were very high and the results were very low because basically of very low capacity in computation and computational power. So there was a first AI winter where AI topics disappeared from research, and it was kind of a taboo to be working there. Then there was the rise of symbolic AI, which is about knowledge-based systems. So as I mentioned before, the knowledge graph and the expert systems. But here also a lot of success happened to start this domain, but expectations also were very high. And let's say the output from it was low and hard to maintain. Then there was a second AI winter, but in the last few years, so in the beginning of the of the century, there was some very prominent successes. For example, in solving chess, like with Deep Blue, recommendation systems with Amazon. You heard about Apple Siri, IBM Watson winning the Jeopardy. And then more recently, this is the second golden age of AI, where there's a lot of investment in it. But we're seeing also much more applications and speaking about it in different areas. And here again, we have a lot of high expectations of AI. And I cannot help but wonder if there would be another winter coming back. And this actually brings us to today. And the question is, okay, we have these large amount of data that were made available by digitalization. We have also a lot of high high computational capacities, because we can do them very cheaply in the cloud, or we can even now buy cheap computational units to have it in house. So how do we leverage this richness and these capabilities in order to do something more practical with AI, or let's say get some value from it that avoids it to go through the winter, a third winter? And in order to answer this question, or at least try to bring some of the components to the answers, I would like to actually give the word to Daniel now, who will be talking more about practical aspects of implementing AI in business context. Daniel, I'll give you the word now, and I will stop sharing my screen.
Thank you, Eliane. And thank you for doing the great intro. So, perfect. Now up to me. So once again, thank you very much for having me here today. So my name is Daniel, and I'm part of the Dataiku family. Maybe a little bit of a sales talk on the beginning. So Dataiku was founded back in 2013 as a startup in Paris, France. In the meantime, we got over 500 people working at Dataiku, and we are active around the globe, serving more than 300 customers. And the thing I'm going to share today is basically also part of the story of the last 6-7 years, where Dataiku has made experiences of using AI, or like Eliane said, machine learning, deep learning, all these technologies within different business use cases in companies. So without further ado, let's jump into the story that I prepared for the next 15 minutes. So the guideline I have is I like to set the stage by presenting you a hypothetical use case from a retail company. And based on that use case, try to approach the myths that are with it. And I have just listed here on the storyboard some of the myths that I would like just to explore. And hopefully we will have some more further questions that we can demystify together with Eliane at the end of the presentation. Now, let's look at a potential retailer. Let's call that retailer Amazon as an example. So all of us, we know that today we just go on the online shop, you know, e-commerce, and we just basically place our orders, and the system suddenly remembers what we like, what we order, how many we order, etc. So basically we are in a classical, I would say, shop and then shipping approach, which is the classical model. But now imagine that Amazon says, I like to optimize all these processes, and I learn from the behavior of my consumers. And actually, I like to change my business model into something which I call shipping and then shopping. It's a huge difference. And now we will explore together what that could mean in terms of this paradigm shift of changing the business model. Because you can imagine that now suddenly some users would say, hey, that's great that you anticipate what I like to have and when I like to have it delivered to my door. But on the other hand, I'm not going to be the guy that is going to do all these return shipments, because I don't want to run back all the time to the post office or calling some agent, say, hey, pick up all the parcels. So for this to happen, we need to do a couple of things. And we look at this a couple of things. Let's imagine the following scenario. So in order to do this paradigm shift of this business model, we need to consider that there are a lot of different business cases or business processes with different tasks in it that we need to address. So basically, we need to dig into all the aspects of our, let's call it value chain, and identify all the tasks that we think together with AI, or let's say machine learning and deep learning, we can solve in terms of learning patterns, and in the way that we can also maybe automate certain processes, or at least provide better decision making for the human in the loop. And there is a statement by some analysts that say companies which will fail to solve within the next 5 years AI, to leverage AI in those business cases, will be most likely out of business. So then for sure, we don't want to happen that with your companies that are today in the audience. So when we look at those business cases, so basically the vision is that we want to address as many business cases as possible. So if we just look at our very simple scenario, and I just picked a couple of use cases here. So of course, the one thing is we need to do some demand forecasting. So we need to know or predict how many articles will be ordered in which quantity by which date. On the other hand, we also have to make sure that if we do something, we will have some payment systems. So we also need to detect, is there any fraud involved in it? Thirdly, let's think about pricing. Is it always the same price tag, or do you maybe need to think about dynamic pricing? So this also, again, is a machine that should maybe start to think, okay, how do I modify that? Maybe some of you already have witnessed that with flight tickets. So if you look at an airline ticket today, and then maybe half a day later, or even 2 days later, the prices change all the time. So this is something what we call dynamic pricing. So the same thing will happen in the retail stores for the same product. Then on the other hand, we of course want to make sure that the customer which is coming to our shop is continuously buying new stuff. So not always the same thing, you know, like on a classical standard way, ship me my whatever pair of socks every Monday, the first week of the month. But maybe we also need to think about retargeting and reprofiling the users. That means we need to think about personalized recommendations, and then of course align our efforts that we do the marketing in a very targeted way. And last but not least, I mean, everything that we just talked about seems to happen just online on the web page. But on the other hand, we also need to think there is some maintenance maybe going on in the backend, because there is some production. Could be as simple as just doing assembly and packaging, wrapping up parcels, but it could be also in another environment that people are really building something at the back end. So you might have a production line. So of course you want to make predictive maintenance, so make sure that your machines are not stopping, and therefore you can continuously deliver your information, or basically your articles. So if you now look at this very simple scenario, so you see in front basically a value chain, and the value chain in the backend has a lot of multiple use cases. Now, the first reaction should be, okay, who is going to do all of those different use cases? What kind of people do I need in order to put that in place? You know, how do I put those things quickly and scalable from test into production? So all these things suddenly start to pop up, and basically some myths come up in my mind that we need to address. And today I just brought a couple of them with me, and I'm going to share it with you. And then hopefully at the end, you will have some further questions to discuss with Eliane and myself. Let's look at the first one. So one bit is always what we hear in business is, oh, we would love to implement this, but we can't find the data science specialist. As already Eliane said on the beginning, you know, does that person needs to be a specialist in database management, database connections? Is it the guy that does data analysis, does ETL, that means extract, transform, and load data that he gets from somewhere? Or is it the guy that asks the proper questions within the businesses to understand what is the exact problem that we need to solve and try to automate? So this is, of course, somebody that needs to have a multiple level of different skill sets. And of course, these kind of talents are not just, you know, for free out on the market and not in unlimited resources. Secondly, we need to talk about the myth about functional domains. We heard that there are different things to be solved. So typically, we usually maybe use the best of breed approach, that we try to use the best technology for a specific single activity that we'd like to solve. So therefore, we will use a set of different technologies. But we also learned in the last couple of years that technologies change. So maybe 2-3 years ago, everybody was talking about Hadoop. Nowadays, everybody talks about Spark and Kubernetes. So all these things happen and change. And therefore, we maybe also need to consider how can we solve the myth of adapting the technology, or at least the way we use the technology. Can we have something in between that maybe, let's say, orchestrates all these technologies we have? And last but not least, as a third myth here, think about when you do some designing of a data science project. Now everybody's happy, we think it's great, and now we need to put it in production. In a real world, in big companies, this is a very tough task to do. So the myth there is, oh, nobody really wants to do it because there's a lot of glue software you need to build. There might be, some governance issues. You need to get a lot of approvals from different areas. So this might take in certain companies up to 6 months to put something from a test to a productive environment. So now basically what we are looking for is to demystify this by putting, design to production in a very quick way, or let's use the word MLOps, machine learning operationalization, in terms of putting these things as quick as possible into a productive environment. So how can we solve this? So there are a couple of aspects that, let's say, data science platforms solving. So what we see on the one side is we identified that there are different talents in companies that can be part of a data science project. So all these talents will do different things that they are really specialized in. And this could be, the one guy is connecting to databases. One guy will be doing what we call the data cleaning, the data preparation. Another person would be maybe doing some nice charts and dashboards in order to visualize the information, because we need to build storyboards that we can explain to the management what we see in the data and what we would like to do with it. And last but not least, maybe we also need to put these things then into production. So we might have people in it, like Eliane said, somebody which is good in statistics, then the other guy is an analyst, another person is maybe the spreadsheet wizard that works with it. So basically what we try to do is, in a data science project, is getting all the personas together in a collaborative way so that they can really build jointly the project. So we don't look just for the one data scientist, which might be not as available on the market as we wish. So therefore, think about demystifying a project in a way that bringing all different talents and personas into the environment. Secondly, we talked about the different aspects of having multiple technologies, and those technologies could change every 2-3 years. Think about the aspect that companies work today on-premise, but maybe tomorrow they're going in one of the public cloud providers, some of them doing hybrid environments. So basically what we need to find is a possibility to orchestrate all these different technologies without losing the flow of our development. That means that what we designed should not be changed heavily in order to make it run on the new environment. So basically, on the left side, we have the the collaboration between personas and different skill set. In the middle, we have the person that are using a orchestration platform that integrates the different technologies. And on the right side, very similar, like Eliane presented, the process of how data science projects run. We will need to find a way, and there are possibilities out there with platforms that allows you to push something from design into production and do the monitoring of it. Importantly, you also need to see that AI projects are not static. And why not? It's not like an ERP system that, whenever you do your accounts receivable or accounts payable, it's kind of like always the same kind of a process and nothing really changes. It's always, you just do the bookkeeping of transaction. In an AI environment, you always get more and more data. The system will start to learn, and the characters, the content of the data, the flavor, the semantic might change. So therefore, the model suddenly starts to drift. So you need to think also on how can you monitor those models in a productive environment and do adjustments. So therefore, you see it, I would see this is like a cycle. So once you build it, you design it, you push it immediately as fast as possible into production, but you also need to do the monitoring of it in order to make changes into the changing environment that you are inside of your organization and in the economics of your activities. Another myth that is always out there is, and this is part also of one of my experiences, is, you know, this discussion about black box and white box. So a lot of these things, people saying, yeah, you just bring one of your machine learning models, you put it in place, and nobody really knows why the machine learning or deep learning model has made certain decisions, why it makes these recommendations, or why it makes this regression, that means prediction of that will be the new revenue, or that will be the number of quantities that I need to put into my stock. In the last couple of years, there's been a lot of work in what it's called explainable AI or XAI. And basically, people have put a lot of work into demystifying how the algorithm works in the backend. We have very good results today with the classical machine learning algorithms. And we also see now the first results with deep learning approaches. For this, basically, the major benefits is if you go and explain the result of your model to your management or the guys that at the end, you know, are financing the project, and they say, okay, do we really want to put that algorithm in place? You will be able to explain why the model has done these decisions. And basically you can then with the human interaction decide the final go ahead, which model you want to really put into the environment in the productive one. Maybe you also think about explainable AI and a white box in terms of governance, because people today need to find journals, they need to do audits, and therefore it's good that you can produce outputs of what the model has been doing so that you can keep track why you have been putting a certain model into productive environments in the past. So this year has been just a couple of examples, you know, from demystifying certain aspects of AI in a business environment. And now let's talk about maybe the last one, about what I call the path to an enterprise AI or an intelligent enterprise. We see basically in the business world, I would say those 5 E's, the 5 major steps that companies are going through. On the left side, basically what we see is the explore phase. In the explore phase, what you see there is typically is you're assembling kind of like the first team. You start to check about your data, you're building maybe data lakes, you start to understand maybe some patterns in it, and you maybe start to work on the first kind of proof of concept, proof of value aspect, or most valuable product that you're going to build with your first machine learning or AI algorithm. But of course, this is not really scaled. So this is just maybe solving 1 or 2 tasks that you have within your organization. But you're starting to get your hands dirty and start to learn how these things behave and what you can do. And maybe you start to measure some first ROIs or TCOs. Then basically in the stage of experiment, you basically start to deploy those projects more into the productive environment and really start to monitor what is going on. You also start to see, can I reuse certain things that I have been doing in one project or another one? So that means basically you start to think about the economics of AI in the sense like, why should I do the same cleaning of certain data sets that I have again and again in my different projects? Maybe I can just reuse some parts of those flows and basically be much quicker and also faster. And then basically you move into what we call the establish phase. That means you're looking at solving the problem of experts by even trying to find ways of doing certain automation in building the models. But you also start to capitalize on previous projects even more. That means you do some reconciliation of certain aspects that you have done. And basically what you also do is you're starting to show multiple task that you have solved to your management and say, hey, look, all the ROIs we now get in those single tasks. And we are now going really into the path of being a fully enterprise AI environment. So by this, you start to really appreciate that you will have to build also an environment where you can monitor all the aspects of your models. That means model drifting, and also build scenarios on how you can handle these kind of changes in a fast way. And basically then the last step is to really go to the full-blown intelligent enterprise by embedding the whole aspects of AI in all possible steps that you see and you can leverage in there. So basically the 5 E's bring you, as you see on the timeline, you know, slowly but in a progressive way, on a scalable way, that brings you the total value at the end. And the total value at the end is, remember the slide where we had about our retail, which has the value chain with multiple business cases. So only we can fulfill our shift of our new business model by implementing as many as possible AI tasks within our business processes. I hope by showing you these first 5 myths out of multiple ones that we have seen with Dataiku in the last 7 years by implementing in our customers, that gives you some kind of a flavor and explanation that they can be solved. There is value, and there is a lot of tool sets available out there that they can help demystifying those things. By that, I'm happy to discuss any open questions that Eliane and myself will have, and hopefully we can give some responses in the next 15 minutes.
Thank you so much, Daniel. Yes, we will be moving into a discussion and Q&A session. So I would like to welcome both of the speakers back onto the screen, as well as Dr. Johan Rudui to moderate the session. Welcome.
Hi, Tiff. Thank you. Thank you both for the presentation. Is Eliane back with us? It's getting late.
I'm not able to turn the camera though, but
here,
I'm here.
Let me do some machine AI trick and start your camera. I have a question to start the conversation, and then again, we have questions from the audience already, and feel free to add on the Q&A, but I'll have a question to start, and then I'll let Eliane carry on the conversation. As we were preparing for this session, Eliane, you mentioned to me that a lot of businesses want to implement AI, and you told me something that I thought was very interesting. You said sometimes they just need an Excel spreadsheet. You don't need to like start thinking AI, machine learning, big data. You say, hey, have a good Excel spreadsheet. But on the other hand, tonight Daniel tells us we have such a large amount of data. If you don't go into this process of implementing AI for your business, you'll probably soon be out of business. So which one, who is right here, Eliane or Daniel or both?
Well, I can start, and then I have a follow-up question about this as well, because actually this is an issue that's happening now. AI is creating a lot of expectations, and there's a gap growing between ambitions, let's say, and dreams, what AI can do, and what is available for the company. In many small businesses, it's kind of very premature to think, let's go deep learning and get the best, let's say, talent out there. And they get here, for example, to this small company, and there is no data to work with. The data management structure is not there to work with, and there's no computation capability. So it's like, I think there is a understanding to have first about what is required to make to use artificial intelligence or machine learning inside the business, let's say, environment. And sometimes you need to start with already making your decisions on a very small database, that small database that you have. We're talking about big data, but there's also small data around there. So, but I think here maybe the follow-up question is that this gap is there, and we need to fill it. But I think it's very natural to fill it very progressively. But then I think Daniel here can follow on this. He showed this. You showed this process at the end where you can move from small step by small steps, right? From prototyping to experimenting and then presenting the results. But how realistic is this? Like from which size of company, let's say, we can start speaking about this, and then how can we acquire the talent that is required for this process?
Okay, thank you for triggering that off. So what we see is a transition. So of course, what we see now in the market, and I'm just speaking on behalf of Dataiku and let's say our competitors, so we all have the same challenge with the companies. So basically what we see today is it depends a little bit on the territory, the country we are in. So let's say continental Europe, US, UK, so they are very mature. So we see that these companies have started to build what we call the digital transformation and innovation. And part of that, they are starting to leverage the data they have been collected over the last couple of years. And now because they have a lot of data sets, they can't just handle that with if-then simple rules with a spreadsheet. So basically they are now really having huge data lakes where they have this information. And now they start to think about how can we understand the patterns we have in there in order to maybe automate certain things. So they are now what I would call in this explore experiment stage, where they really start to dig into these informations by applying not a data science platform on the beginning. So they use the classical, let's call it the Python R approach. So they're doing some scripting with notebooks. So they're getting their feet dirty by, trying the first couple of projects. And once they see it is working, now they start to think about, okay, how can we scale that? And then basically bring that to an environment where I can use maybe my staff of maybe 20, 30, let's call them data scientists, but you remember I call different skill sets within it. And then basically put that on a platform so they can handle as many use cases as possible by doing the scalability, taking away certain repetitive tasks by having a platform in it that takes care of that. On the other hand, the other question you said is about, is it the company size? And I think, no, it's not a matter of a company size. I think it's rather a matter of how the company operates with data. We have companies that are, I would say, rather small in terms of definition when you look at revenue and number of people, but they do a lot of collecting of information, by web clicking, some SEO information they get, etc. So they are starting a lot of those data to collect. And now the question is, how can we handle that volume? So therefore, I think it's not just a matter of size in terms of people and revenue. It's more a matter of size in how many different data sources I have and how many data I'm collecting in those data sources so that I can start to build meaning out of the patterns I see.
Yeah. There's actually when you start with these AI projects and we see the potential and start prototyping, we often forget about the risks that are involved, right? Basically, we try to get as much value as we can, but I think recently, and this joins a question that was asked by Susan, is so we're starting to see more and more discussions about bias in deep learning and specifically, but in machine learning in general. What is your take on this? Like, how could we discover bias from the data we have? For example, let's say in a recruitment process, this is being asked quite often. What technologies are there? Like, how can we discover? Is there a way currently? Like, we're getting with explainable AI, we're getting much better information. What do you think about that?
That's a very tough, challenging question. So maybe we have to put it that way. So of course, garbage in, garbage out, and basically then bias also works in AI. So if you don't collect the proper data sets, then basically you will also maybe build models that are based on, let's say, not a well-represented environment. So you still need a human in the loop. So that means you still need to have somebody that is part of the design process, which will ask critical questions and say, did we really incorporate all the different data sets that we need? And are the data sets representing a sample which is really relevant to our business so that we don't face the bias problem? So that's the one part where you need the human in the loop. The second one is maybe a little bit related to the explainable AI, is that you start to use these kind of explainable AI tools to start to see how the model has been doing some decisions. So you can go step by step, and of course, the easiest case would be with the decision tree. With neural networks, yes, it is more complicated and difficult, but what we also see is 80% or even more of the projects that we have done with the customers, they use the classical machine learning libraries to do classifications and regressions. And for them, we have the explainable AI ready, so we can use these functions to go and check why the model has been doing certain things. And the last thing what we see is you can build what we call scenarios around a data science flow, so that when you move to in production, and I will use now the word model drifting, so you not just want to make tests if your score, your accuracy is changing, but you also start to build in matrices and checks on the data sets that you're continuously measuring. So it's again part of the human to make sure that you're building the proper checks into the single steps of a process so that you can catch the bias as early as possible.
Mm-hmm. Perfect. Maybe a last question about human resources. So we see that there is a lot, this whole process is very much dependent on the skills that we have in the company. So, or the skills that can be acquired by the company. So I think here it's interesting to maybe to understand when it is worth to train internally and when it is worth to outsource this effort. Of course, not everyone, like now it looks like to be an AI expert, you have to do a PhD. Yeah. So when it becomes possible actually to do it internally and then outsource.
Okay. So that's why I brought back again that slide here when we talk about, you know, the talents. So there is also some notion in the market that we see with the companies that they say the new citizen data scientist. So the citizen data scientist is maybe not the PhD guy, but it's maybe somebody that has already a good background in working with data. So he's been maybe doing some ETL stuff. So he can be already part of those projects. And with the new approaches that we can use auto ML, you know, the automatic machine learning, at least if he understands, oh yes, I would like to do a classification or I would like to do a regression, he can maybe select the proper feature or the target variable and say, please, algorithm, just do something for me, just to get kind of like a first view of the experiment. And then you would then involve in a second stage, really the data scientist that really understands why the model has been doing certain things, start to work what you call the hyperparameters to improve the models the way that it basically brings the result. Now, to answer the question concretely, we see that certain companies are starting to build their own people with that skill set. But on the other hand, they say, no, I'm pretty happy to have the business analyst, the guy that is doing ETL, data cleaning and preparation, and maybe just quickly some auto ML. And then I will involve some experts externally that will help me really to build the hyperparameter optimization of the models. And maybe coming back in the iteration, say, guys, I think from my experience seen in other projects, I think we should have some additional features that we can put into the model, which will improve the quality. So therefore, yes, you need the experts, but you don't need them from the end-to-end process, but only particular, maybe in optimizations in an iterative way. And those experts could be internal, but of course, also coming from external with the proper background from their, let's say, computer science, statistics, or data science, university education to get today.
Okay, perfect. I think we're up with the time. I'd like to thank you, Daniel, again for your participation. Maybe just last words. What would you like to leave us with? In your opinion, in this crisis that accelerated digitalization, is AI benefiting from something, or is it also?
I actually think the crisis is good for AI, because that basically leads to companies to rethink the certain business processes and which task of the business process could be automated or improved for decision making. And therefore, I think AI has now the best time to go into companies and basically show them the possibilities, assuming the company is from the mindset willing to accept innovation.
Perfect. Thank you very much.
You're welcome.
I think we can wrap it here, and I give back the word to Tiffany. Thank you, Johan, as well.
Thank you.
Thank you so much, speakers, and thank you to all of you for joining us today for the third day of Conexkt Days. We're delighted to have you spend this week with us, and tune in tomorrow for some more marvelous talks and conversation around the future of work and ethics and innovation. So make sure you don't miss out, and we will see you there. Have a good one.